Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, we are going to learn about colorimetry. What is colorimetry? It is the most common analytical technique used in biochemical estimation in clinical laboratory. It involves the quantitative estimation of color. A substance to be estimated colorimetrically must be colored or it must be capable of forming chromogens colored complexes through the additions of reagent. Colored substances absorb light, you know that, in relations to their color intensity. Color intensity will be proportional to the concentration of colored substance. Colored substances absorb light in relations to their color intensity. The color intensity will be proportional to the concentration of colored substance. The instruments used in this method are colorimeter or photometer or observometer or observance. Now friends, what is the principle? The properties of absorbing certain wavelength of light when a monochromatic light is passed through them. The amount of light absorbed or transmitted by a colored solution is in accordance with two laws, Bayer's law and Lambert's law. So what is Bayer's law? When a monochromatic light passes through a colored solution, amount of light transmitted decreases exponentially with increase in concentration of colored substance. That is, the amount of light absorbed by a colored solution is directly proportional to concentration of substance in the colored solutions. Now Lambert's law. The amount of light transmitted decreases exponentially with increase in path length, diameter of the cuvette or thickness of colored solution through which light passes. That is, the amount of light absorbed by a colored solution depends on path length of cuvette or thickness or of the colored solutions. Now, combined Bayes-Lambert's law is thus expressed as amount of light transmitted through a colored solution decreases exponentially with increase in concentration of colored solution. An increase in concentration of colored solution and an increase in the path length of cuvette or thickness of the colored solutions. My friends, you can see in this pictorial diagram source of light source, slate, lens, filter, cuvette, photocell and output. This is the part of colorimeter. Now light source is tungsten lamp and slate it is adjustable which allow only a beam of light to pass through. It prevents the unwanted or stray light. Condensing lenses light after passing through slit falls on condenser lens which gives a parallel beam of light. Now what is the filter? Mode of colored glass. Filters are used for selecting light of narrow wavelength. Filters will absorb light of unwanted wavelengths and allow only monochromatic light to pass through. For example, a green filter absorbs all color except green light, which is allowed to pass through. Light transmitted through a green filter has a wavelength from 500 to 560. Filter use is always complementary in color or to the color solutions. Now, filter use in colorimeter. Yellow green, color of the solution. Yellow, orange, purple, blue, green, blue. Filter violet, blue, green, orange, red. Wavelength range 390 to 490, 430, 460 to 540 nanometer, 480, 500 to 590 nanometer, 540, 580 to 650 nanometer, 600, 650 to 700 nanometer, 670. Now, cuvette, sample holder. The monochromatic light from the filter passes through the colored solution placed in a cuvette. It is made up of special glass, plastic, quartz material. It may be square, rectangular, round shape with fixed diameter, usually 1 centimeter, and having uniform surface. The colored solution in the cuvette absorbs light of light, so remaining is allowed to fall on detector. For example, a solution of red color transmit red light and absorb the complementary color green. My friend, what is the detector? Detectors are photosensitive elements which converts light energy into electrical energy. You know, my friend, the electrical signal generated is directly proportional to intensity of light falling on the detectors. What is the output? The electrical signal generated in photocell is measured by galvanometer, which displays percentage transmission and optical density. So you can see the optical density and percentage transmissions. Up one is optical density, down one scale is percentage transmission, and this galvanometer. Use of test and standard and blank. In colorimeter estimations, it is necessary to prepare a blank B, a standard S, and test sample T. Now, use of test standard S and blank B. In colorimetric estimation, it is necessary to prepare a blank B, standard S, and test T. Test this solution is prepared by treating a specific volume of a specimen, blood, urine, etc. with reagents. What is the standard? Prepared by treating a solution of the pure substance of unknown concentration with reagent. Primary standard, the same substance is used as a standard one which is to be estimated. For example, pure glucose is taken as standard in estimation of blood glucose. Now, secondary standard. Here is the substance taken as standard is different from the substance to be estimated. This substance taken as standard should match the color of the final product. For example, methyl red is taken as standardin estimation of serum bilirubin. Now, blank prepared by rule out color produced by reagent alone. Two types of blank: distilled water as blank or reagent blank. Reagent used in the estimation is taken as blank. Calculations: concentration of substance in milligram per 100 milligram or gram per 100 ml of substance. OD of the test, OD of the blank divided by OD of standard minus OD of blank. Concentration of standard divided by volume of test sample multiplied by 100. So, application of colorimetry assay used in determination of amount of many substances in blood, urine, saliva, CSF, and other specimens. Example for common colorimeter assay are determination of blood glucose, blood urea, serum creatinine, serum protein, serum cholesterol, serum inorganic phosphate, urine creatinine, and glucose in CSF. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.